Hi. So what we were talking about last time was how to take the derivative of the product of two functions. So naturally, it's very easy to ask yourself, well, if I know how to take the derivative of the product of two functions, what happens when I divide two functions? Can I still take the derivative of that? And the answer, of course, is yes. And we're now going to talk about what we know as the quotient rule for differentiation. So what the quotient rule says is if we have f of x and g of x as two functions that we can take the derivative of, then the quotient of f and g, or f of x divided by g of x, we can also take the derivative of. And it's a differentiable function, and it's going to be differentiable wherever g of x does not equal 0. Because if g of x was equal to 0, we would have a 0 in the denominator of this fraction, which means that we would have an undefined value. So the derivative of f of x times g of x, or d dx of f of x over g of x, looking at the second formula on your screen, just because the first one has a lot of d dx's in it, and it's very large and confusing to look at, kind of overwhelming. I prefer the second one. So the derivative of f of x times g of x is g times f prime minus, that minus sign is important, f times g prime all over g squared. Or the way that I like to say it, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, if you remember our power rule, our product rule rather, we knew that it was g times f prime plus f times g prime. So you can see how the ordering is exactly the same, which is why I always memorized the product rule in this order, because it was completely the same as my quotient rule. All I had to do was change the addition sign to a subtraction sign in the middle, and then remember to divide by g squared. So just like last time, we're going to go through some important notes and then do some example questions. So just like the derivative of the product of two functions is not the product of the derivatives of the functions, same thing applies here with the quotient. So the derivative of the quotient of two functions is not the quotient of the derivatives of the two. So in other words, d dx of f over g does not equal f prime over g prime. Which again, if we went through the proof using the limit definition of the derivative, we would be able to see that. But again, it's very time consuming, so we're not going to present that here. That you could easily find that somewhere on the internet or probably in your textbook, or you could always ask your professor to go through it with you if they have not. Okay, so our first example for today is going to be finding the derivative of 5x minus 2 all over x squared plus 1. Okay, so first let's write our quotient rule up on the board. Just help us remember what to plug into. So our derivative of f over g is just g times f prime minus f times g prime all over g squared. Okay, so just like before with the product rule, let's label what we're going to consider f and g. So we're going to let f be the top, g be the bottom, which is always the case for quotient rule. For product rule, you can pick them in either order, but for quotient rule, f is always the top of your function, and g is always the bottom. Okay, so finding little f prime for our formula, we're going to take the derivative of 5x minus 2, which is just going to be 5. Finding g prime, the derivative of our denominator, is just going to be 2x, using our power rule on both of them. Okay, so now we're ready to plug into our formula. So we're going to find that f prime of x is going to be equal to g times f prime. So we're going to have x squared plus 1 times 5 minus, now you always want to make sure to put parentheses after the minus sign to make sure you distribute that negative, minus f, which was 5x minus 2, times the derivative of g, which was 2x, then all over g squared, so x squared plus 1 quantity squared. So now we're going to distribute through our top since it's a fairly easy problem to simplify, and we'll see what we get. So we're going to get that f prime of x is equal to, first let's distribute that 5, so 5x squared plus 5 minus, keep our parentheses there for right now, 10x squared minus 4x. Now what we're going to do is I'm going to distribute this minus sign inside of the parentheses, so this is going to become negative, and this minus 4x is going to become positive, and then this is all still over x squared plus 1 squared. We won't square that out, we'll leave it as is. Okay, so now if we go through and distribute, we're going to find that f prime of x is really equal to negative 5 x squared plus 4x plus 5 all over x squared plus 1 all squared. So that would be your final answer there. Again, you could leave it probably up here in your first step if that's okay with your professor, your teacher, whoever would be grading a test or something like that. You always want to check to see with them how far they want you to simplify, or you could easily simplify to the bottom step. Okay, so let's try another example. Okay, so let's find the derivative of f of x equals tan of x. So initially looking at that, you're probably wondering, why the heck did she put finding the derivative of tangent of x in a video about the quotient rule? There's no quotient going on there, it's just tan of x. Well, if we rewrite this, we get that f of x, well, tangent is just sine of x over cosine of x. So this actually is a quotient rule problem. Okay, so just like we were doing before, first we're going to write our quotient rule up on the board. So the derivative of f over g is g times the derivative of f minus f times the derivative of g all over g squared. Okay, so our numerator is f, our denominator is g. Now let's find f prime and g prime. So f prime is going to be the derivative of sine, which is just cosine of x. G prime is the derivative of the cosine of x, which is just negative sine of x. Okay, so now we're ready to plug into our quotient rule formula and find what the derivative of the tangent of x is. So f prime of x is going to be equal to g times f prime. So g was cosine of x times f prime, which is also cosine of x, minus f, which was sine of x, times g prime, which was negative sine of x, all over g squared. So we're going to get cosine squared in the bottom. Okay, so again, we're going to simplify this a little bit and see what happens. So cosine times cosine is just cosine squared of x. Now we have a negative sine of x over here with this negative sign, so they're going to cancel with each other and become positives. We'll circle it instead so it doesn't look like I'm saying plus or minus. So we're going to get cosine squared plus sine times sine is sine squared all over cosine squared of x. Now you might be saying, that's a really messy derivative for tangent. That's a lot of stuff to remember. Well, we're going to use some trig identities now to simplify it and show that it's actually a really easy thing to remember. So using the Pythagorean identities for trigonometry, we know that cosine squared plus sine squared of x, that's just equal to 1. So we get 1 over cosine squared of x. But we know that 1 over cosine is just equal to secant, so 1 over cosine squared should just be secant squared. So in other words, the derivative of tangent, d dx of tangent, is just equal to secant squared. So that's really important. That's something you definitely want to have memorized as well, so that every time you see a tangent inside of a problem, you don't have to go through and do the quotient rule to find out what the derivative of tangent is. So that's how you go about finding the derivative of tangent. So that's another one that you're going to want to have memorized, just like you have sine and cosine memorized. So now we're going to go through and show how to find the derivative of the secant of x, and then we'll go through and show you what all of your trig function derivatives are. So again, this one is kind of a hidden quotient rule problem. We don't know what the derivative of secant of x is right away, so that should indicate that we need to rewrite it. So we know that secant of x is just 1 over the cosine of x. So now we're going to have our quotient rule because we've got the quotient of two things going on. Okay, so we know that the derivative of f over g is just g times f prime minus f times g prime all over g squared, where f is going to be our numerator of 1 and g is our denominator of cosine of x. So f prime, the derivative of 1, since 1 is just a constant, is 0, and derivative of cosine, we know, is negative sine of x. Okay, so now we're ready to plug into our derivative formula. So f prime of x is going to be equal to g, which is cosine of x, times f prime of 0. So we have cosine of x times 0 minus f, which was 1, times g prime of negative sine of x, all over the bottom squared, so all over cosine squared of x. Okay, so let's see what happens. Cosine of x times 0 is just 0, and then these two minus signs will cancel and become positive. So overall now, we get that we have sine of x over cosine squared of x. So again, just like in the last problem, we were finding the derivative of the tangent function, we're going to use our trig properties to kind of rearrange this to make it a little nicer for us to remember. Well, splitting this up, this is really just sine of x times 1 over cosine of x times cosine of x, because I can rewrite cosine squared to just be cosine times cosine. Well, splitting our fractions then, since this is multiplication and we can do that, this is just sine of x over cosine of x times 1 over cosine of x. But we know that sine of x over cosine of x is just the tangent of x, and 1 over cosine is just the secant of x. So that means that our derivative of the secant function is just going to be tangent of x times secant of x. So again, another thing that you're going to want to have memorized. So you might think it's a little funny that the derivative of the secant actually has the secant in it, and that does happen. So sometimes the derivative of a function of itself will have the function inside of the derivative. Didn't really say that real clearly. So in other words, if when you take the derivative of certain functions, the function is going to pop up again somewhere in the derivative. Which is really nice, and you'll start seeing that more and more as you get into different types of functions, especially when you get to exponentials. So now on this last page, what we have is we're just going to talk about the different trig functions. So you can use this quotient rule process to find the derivative of all six of your trig functions. Specifically for these four on the bottom, rather, that are defined in terms of sine and cosine. So these come from your quotient rule. Whereas the top two, we did them before, so these are just our known ones. So as long as you know the derivative of sine of x and cosine of x, you can always find the derivative of the other four functions. So we got this nice little handy-dandy chart for you. We'll just go through it real fast. So we know that the derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. We found today in our second example problem that the derivative of tangent is secant squared. And then we also did, in the last example problem, the derivative of secant of x is just secant times tangent. Now we could have gone through and done the derivative of cosecant of x and cotangent of x the same ways that we found tangent and secant. And when you do that, you get that the derivative of the cosecant of x is negative cosecant x cotangent, and the derivative of cotangent of x is negative cosecant squared. So now you might be saying this is a lot of stuff to have memorized, and it is, but there are a lot of patterns that show up in trig functions. Now you might notice that if there are three trig functions that have negative derivatives, and it's really easy to remember them by the simple rule of starts with a c. So we know that if it starts with a c, it has a negative derivative. So negative d dx. Which you can take a look at this here. We have cosine, cosecant, and cotangent having derivatives of negative sine, negative cosecant, cotangent, and negative cosecant squared. Okay, and you can also see that they kind of pair up with each other. So we knew that the derivative of tangent of x here was secant squared. So in other words, the derivative of sine of x over cosine of x just turns out to be 1 over cosine squared of x. Well, that makes sense then that the cotangent of x, the opposite of tangent, the reciprocal function, so the derivative of cosine of x over sine of x, well, that's just negative 1 over sine squared of x. So you can kind of remember it like that. So if you know that tangent of x is secant squared, it should be hopefully a little easier for you to see that, oh, cotangent should just be negative of 1 over sine squared, so negative cosecant squared. And then it's the same thing with the secant and the cosecant. For the secant function, we saw that it was secant times tangent. So for the cosecant function, well, since it starts with a c, it has to be negative. We're just going to use the other two functions that are kind of related to the secant and the tangent. We're going to use kind of those opposite ones, so cosecant of x and cotangent of x. So this is definitely something to have memorized. You want to really know your 6 trig functions and their derivatives really well because it's going to speed up how long it takes you to do your homework problems, and it's going to really help you on tests and quizzes where you might not be given a note card or a reference sheet where you can write these down. Okay, well, thank you so much for watching. Have a great rest of your day. I hope this helped.